All right, hey everybody, my name is Isaac. I'm going to be talking today about a DIY Gosec, basically how you can detect complex code patterns in your code using a tool that I've been working on, which is open source, called Semantic Grep. So let's get started. So a little bit about me. As mentioned, I'm one of the co-founders at R2C. We're a San Francisco-based static analysis startup. And our mission is to basically build tools for static analysis that developers are actually going to want to use and will hopefully improve the security of the code that we all write. So the TLDR for this talk is basically that computers are really good at consistently applying human experience. And our thinking is that the future for security and tooling and automation is less about pointing out vulnerabilities and playing whack-a-mole with like, oh, here's a vulnerability, there's a vulnerability, and more about guiding developers into a paved road that's kind of known to be safe. So default safe frameworks, things like React if you are talking about the front end, or ORMs if you're talking about interactions with the database. And in order to like provide this paved road, we could use tools like grep, but they're not really expressive enough to do what we want, whereas the traditional static analysis tools tend to be too complicated or too slow for enforcement. So what we want to have is a tool that is fast, easy to use, code aware, hopefully multilingual, and ideally open source. And that's what we're going to be talking about. So that tool is Semgrep, which is designed to provide lightweight static analysis for many languages and define bug variants with patterns that look very similar to source code. So in this talk, we'll talk about other approaches that you could use, so grep and abstract syntax trees. We'll go over a tutorial and some examples, and then we'll talk about how to use Semgrep in a production flow, basically. So to start off with, here's a graphic that comes from a presentation by the Instagram engineering team talking about the sort of spectrum of tools that are available from a static analysis perspective. So on the right-hand side, you have whole program analysis, which they characterize as, hey, this is really powerful, but it's super complex. On the other end of the spectrum, you've essentially just got regular expressions, so the sort of things you would use grep with. And these are easy to use, like very easy to write. They're pretty understandable. They're easy to edit, but ultimately they're pretty dumb. And then somewhere in the middle, you have things like AST-based linters. So you might be surprised that people would even consider using grep and consider using it as a static analysis tool. A number of places, though, like if you're just looking for, hey, like does this code use the unsafe package in Go? If you grep the code for unsafe, you might have a lot of false positives, but you're pretty much guaranteed that like if somebody is using unsafe, you're still going to detect it. So a surprisingly large number of teams that I've talked to have actually gotten a decent amount of utility just from using grep. But unfortunately, the problem with grep is that ultimately it's not aware of the structure of the program. So it's easily confused by white space, by like import aliasing, by commented out code, things like that. And ultimately, this comes back to, yes, you can solve problems with grep, but as XKCD says, if you had 99 problems and then you used regular expressions, now you have 100 problems. So maybe there's something that we can do that's a little better. And the fundamental issue is that, look, when we talk about finding code, code is not a string, it's ultimately a tree. The first thing that a compiler front end, and especially the Go compiler, is going to do is it's going to take an example like the one on the left, and it's going to parse it into a tree-like structure, as represented by the pseudocode here on the right. And so there are tons of tools that are allowing you to do AST matching in the Go space. GoLint, Gosec, static check is another one. Ultimately, like in order to do a good job at AST matching, you need to become an expert in the AST syntax for every language. So Go is actually somewhat unique in that there's an officially supported AST package, which provides an interface to you as the developer. But you need to learn the syntax of the Go AST. And then also, you need to be able to cover all of the idioms in the language. So if there's more than one way to do it in Go, you need to be able to write the AST matching code to handle each of the specific AST constructs. So here's an example from Gosec, actually the code on the right, we've got about 94 lines of code. You can see the sort of like how we're manipulating the AST.node types coming into this. And we're finding calls to like old or blacklisted cryptography functions in this example. It takes about 94 lines of code. It's not the most difficult thing in the world to write, but it's a significant effort if you're thinking about trying to get you or somebody else on your team spun up on interfacing with the Go AST. So if you wanted a commercial tool, there are commercial static analysis tools for security, especially. They tend to be pretty complex. They tend to be fairly slow and fairly expensive, and actually Go has really been an afterthought for a lot of those languages. I should mention for Go, there's specifically, it's not a multilingual tool, but there's a really cool tool called GoGrep, which if you haven't heard about, is similar to Semgrep, which is awesome. You should go check it out. So Semgrep tries to occupy a space in the middle where it's smarter than the AST-based lints, but it combines the sort of programming power of the whole program analysis with the simplicity of the regex-based approach. So I'll let you judge for yourself how successful we've been at that. But here's the TLDR. So it's supposed to be pretty lightweight and customizable. There are already hundreds of rules that have been written by folks in the community. So it's designed to be batteries included. It's designed to be pretty fast. It's designed to run offline on uncompiled code. And rather than having to learn some super complicated syntax, the patterns are actually going to be just Go code. So the intuition behind Semgrep is that you can grab a like snippet of code and you can convert that into the AST, the tree representation, and then use it as a pattern matcher. And so now you have your like target code that you're trying to search. You convert that into an AST. Now you just have a tree matching problem between the two. So let's see what that looks like. There are just 2 changes to the underlying source code grammar that Semgrep adds. So basically, like if you know Go, you know how to write Semgrep patterns for Go already. I'm just going to show you 2 extensions that we've added that make it easier to specify certain things. So for this, actually, I'm going to be using a live editor that we have, which everything that I'm going to show you in the live editor, you can run offline. So if you locally install Semgrep, you can just pass what I'm putting here in the pattern box as a -e argument to Semgrep and then run it on the source code. Using the live editor is just kind of helpful to like quickly illustrate and iterate. So if I wanted to find like bad crypto calls, so like RC4, run code 4 is a like very, very old encryption algorithm that nobody really should be using anymore. Unless you have really good reasons because backwards compatibility or something like that. So what I can do is I can just copy code directly here from my test code into my Semgrep rule. And I'll say, hey, rc4.newCipher key. So this is valid Go code. It's also a valid Semgrep search pattern. And if I click run, it's going to find line 12 and line 15, which is pretty cool. So now I've actually, I can run this. Like it's got a little share URL here. I can run this locally on my code, which is kind of fun. If I click this drop-down button, I should just be able to pip install Semgrep, and then I can say Semgrep --config, pass it the short URL, and run it locally, or put it in CI integration, stuff like that. But you'll notice that we're not triggering right now on line 13 because here key has a different name. So we're just matching on the direct name of this variable here, and really, we would like to say, actually, hey, developer, really anytime you're instantiating an RC4 newCipher, I would like to trigger on this. So for this, there's an operator that we have, the first of 2. So the first operator is called the Ellipsis Operator. And so if we put a ... here, now we'll just match on 0 or more arguments of any type to this function. So if I run that, you should see that, yep, successfully, we're triggering on line 13 here, which is pretty cool. And then if we were grepping, if we were writing a regular expression for this, we would also be triggering on line 20, but we're not, which is great. And then we would probably also, with our grep-based expression, we would be triggering on line 22. But because Semgrep is code aware, right, it's actually lifting into the AST representation, it's not triggering on either of those. So that's pretty neat. I guess I should maybe pause and see if there are any questions, or I'll just say, feel free to interrupt me if you have questions. I have the live stream open in another window, so I am looking at if anybody has questions that I can answer. Cool. So that's like a really basic example, probably like the easiest example we could imagine for finding banned functions. What about something that is more Go specific? So, like I talked earlier about, hey, if you have unsafe in your Go program, you're kind of opting out on a lot of the protections that you should be getting from, the Go runtime in terms of memory safety or things like that. So we might want to write a rule that's basically like, hey, like, is there really a good reason to be using this unsafe feature? Maybe we have a developer who's a junior developer who just like copy and pasted some code snippet off of Stack Overflow. And we just like to let them know, hey, like, yeah, actually, this is not really what I would like you to do. So here again, I'm gonna just copy and paste some code, unsafe.pointer. I'm gonna replace the arguments with this ... operator. I'm gonna run it. Looks good. We're triggering on line 18 and line 19 or line 20. But we also have there are a couple different functions underneath unsafe, right? So there's like unsafe.pointer, which we're using. There's also unsafe.sizeof, and in fact, there are more. So here's the second and final thing to learn about Semgrep. If I want to use a wildcard for the name of the function here, or actually a wildcard for any identifier in the program, I can use what we call a metavariable, but basically just like a variable that starts with a $sign and has all uppercase for the variable name. So here, I'm basically saying, hey, like any unsafe dot whatever, don't care, with 0 or more arguments, we should trigger on. So if we run this, we should see that we're now triggering twice on line 18, which is exactly what we hope for. And then the thing that's kind of cool is if I switch into the advanced mode here, this has actually like YAML behind the scenes. So like here is the YAML file. I've got an ID for my pattern. I've got the pattern itself. And I can put a message that says basically like, hi developer, please don't use anything from the unsafe package in our code base found. And then I can actually reuse the variable name that I used before. So I can have a message that's actually like highly specific. You can see over here, we're saying, hey, found pointer, found size of, found pointer to the developer. And we're going to come back and reuse that functionality later on when we start to write more complex patterns. But hopefully you're getting the picture now of, I see, okay, so we're parsing, like this pattern here. We're using the same parser that we're using on the Go code. And this makes it very, very easy to just rapidly prototype, oh, like I think this might make a good linter check. Let's run it on the code base. Let's do some iteration. Let's see how frequent or common this would actually be inside the code base. So now let's look at an example that is actually about configuration inside code. So not a function call or anything like that. In this example, we've got somebody creating a TLS client, and they have a specific config that they've set up for that client. So similarly, we're going to try to match on, hey, look, if somebody's setting the minimum version to be SSL 3.0, I don't know how much you know about the sort of like SSL TLS history, but SSL 3.0 is an earlier version of TLS, and basically it's not supported anymore by pretty much any browser because it had so many deep security problems. So in this example, I'm basically going to come through and I'm going to say tls.config, and then I'm going to use the ... operator to say, yeah, I don't care about what comes before this in the config, but anytime you have min version, I'll just copy this directly from the code, min version TLS 3.0, and then I don't care about what comes up after that in the config. I'm going to want to match on it. So that's pretty cool. Like here, again, like what's happening is that we're just parsing this into the AST form, and then we're converting it into a matcher that is automatically going to pull up line 15. The next question might be, okay, like what happens, what about other things? So like here, there's another flag, like maybe I don't just care about the min version. In this case, we're using version TLS 1.0, which is actually pretty much okay. But the developer has specified this flag that says insecure skip verify. So that's not great. This is basically going to say like, yeah, we don't care about actually checking the veracity of the server certificate. So you can actually create multiple patterns at the same time. So here I just press this plus button. Behind the scenes, this is going to edit the YAML for me, and I'll show you what that looks like. But again, I'm just going to copy and paste my first pattern. I'm going to come back and grab insecure skip verify, and I'm just going to replace this section here. And if I click run, we should now trigger on line 26. So yep, even though min version is set correctly here, the second clause inside this is triggering for us successfully. And if I switch over to the advanced view, you can see that we've nested these two Semgrep pattern keys under a key named pattern either, which is doing the magic for this behind the scenes. So if we look at that, I have that example here. There's also in our documentation a whole bunch of details about, okay, in the YAML syntax, what are the sorts of operators that are available? And some of them are actually quite interesting. You can combine Semgrep expressions with a regular expression, which is kind of cool. You can look for patterns that are inside other patterns. And my personal favorite is that the outer shell of Semgrep is actually written in Python, which is great for just kind of like generic scripting. So you can actually have a pattern-aware Python and use Semgrep to extract the abstract syntax tree, but then have Python code basically providing arbitrary logic of like, oh, like should we trigger here or not, based off of the variables that we captured using Semgrep. So I think one of the other cool things about Semgrep is that, you know, normally when you grab a linter or a security tool, they are shipping with essentially a lowest common denominator rule set. But a lot of the time, the things that are the most interesting bugs at your organization are things that are super specific to your organization. So here's an example that we've constructed to kind of show this, where we've got a financial trading application. And in this application, you have to call verify transaction on every object before you call make transaction. So this is just like a very basic example of something that is designed to be very business specific, right? It's like, oh yes, nobody would ever ship a linter rule with this kind of problem, but it could be something that is actually highly valuable to detect inside our organization. So here we have a couple of examples. So like on line 16, you can see this is good. We call verify before we call make. Line 22, this is bad. We just call make transaction. Line 27, we call make transaction and then verify transaction. So that's bad. And the rules that we've got here, you can see I'm using the two concepts that I told you about before. So I'm using the ... operator to say, hey, I don't care about what becomes before or what comes after make transaction. I don't care about the arguments to it. I don't care about the arguments to the parent function. I'm abstracting away the method call. And then if you look at the advanced view of this, I'm actually using that method call inside the message that I'm printing out. And then I'm grabbing, I'm triggering on any function that has make transaction inside it, but then I'm filtering out any function that has verify transaction before make transaction. So the reason I'm showing you this example already filled out is because it's not quite done. There's actually a bug in it. Maybe you've realized it already if you are an astute watcher. So if we look at this one, we're not triggering on line 56. And on line 56, inside this function, we've got verify transaction called with other, and then make transaction called with T. I think the stream may have switched over on the live stream, guys, because I see it's back to the breakout room. Oh, okay, now it's back. Awesome. And let me know if this is not big enough or like zoomed in on the text. Just let me know. So anyways, if you were following along, like you may have already figured out the solution to this. So I'll give you a second to think about it, but then I'm going to jump into it because we're short on time. So if I jump in here, basically I need to say that, hey, whatever the argument to make transaction is, transaction here, that needs to be the same argument for the argument for verify transaction needs to be the same argument as make transaction. So now I've made my filtering out case a bit more precise. And if I run this, we now successfully trigger as well on line 56 where we called verify transaction with something other than make transaction. So that's pretty cool. The last example I'll show you is totally different. So this has nothing to do with bugs at all. Let's imagine that we wanted to just get a comma separated value file with a list of everything inside our application in terms of the routes that the application has. So I can basically come in here, I can say, hey, like app.router.handlefunc. So this is using Gorilla. Put the route here, replace this with handler. And then this would be my HTTP verb as the method, the last thing. And if I run this, we should trigger on lines 14 through 18, which is pretty cool. And then what I'll do is I'll switch over here and I'll write a message and I'll just say route, comma, handler, comma, HTTP verb. And you can see the matches that I'm getting out. So if I'm running Semgrep locally, I can pass it a --JSON flag that will give me these as JSON, or I could just use this CSV type output. And I'm basically using Semgrep to just extract information from the structure of the program and convert it to another format. This is cool because so like here's an example application that we at R2C have built. So we use this to do essentially a code inventory. So we basically extract from the application, hey, like what are all of the routes that we have? If there are decorators on the routes, this allows us to look for anomalies like, oh, you know, we required authentication for this one route, but not for this other one. That's kind of weird. And you know, like trigger or send notifications in Slack or other things. Not for every pull request, but maybe for pull requests that are adding or removing routes to the application, kind of changing it in a more semantic way. So I covered pretty much everything you need to know. Semgrep is a pretty simple tool, but getting to all the applications is a bit more complex. So if you're looking for more goodness, there's a tutorial at semgrep.live/learned. The last thing I wanted to talk about is the registry. So if you've been watching this and you've been like, huh, okay, DIY Gosec, that sounds cool, but you know, I don't really have a lot of ideas for like rules to write. We actually have a registry contributed like a couple hundred rules from the community that like a bunch of people have written Go rules for. There are also people who have been writing rules from the community that are like slated to make it into the registry but aren't there yet. So probably the like most well-known person in the Go community has been Damian Kursky, who's the author of Go Perf Book, who has just been writing, I don't know, he's probably written like a couple hundred Semgrep patterns at this point, looking for, you know, like just kind of like various smells or interesting things. I see there's a question in the chat about like grep and sed for search and replace. I will show you something about that later on in the presentation. I think we're about to get to it. So real quick, because I promised I would show you how to set up Semgrep inside CI. So here's an example, an Apache project. We're like merging in 20,000 lines of code, and we have Semgrep running in CI. There's some overhead to the CI things, but Semgrep actually runs in about 4 seconds on that amount of code, which is pretty good. And so if you go to the GitHub repository for Semgrep, which you can get by going to semgrep.dev and then clicking on the GitHub thing in the top left, there's a whole integrations doc that talks about all of the integrations that we have set up. So the Semgrep core engine has a bunch of features which are pretty useful. One of the ones that we haven't really had time to talk about is what we would call code equivalences. So for instance, if there's more than one way to do it in the program, like for instance, if you are talking about like, hey, I want to call, like find everything where you're saying, this is a call to dangerous method 1 with a string as the first argument. Let's imagine somebody says like x equals a string, and then they call dangerous with x rather than the string. Well, Semgrep should be able to figure out for you that that's actually the same as just calling it with a string directly. And so the engine actually will do that, and it has a bunch of cool equivalences that are basically saying, hey, like actually, maybe, you know, for your rule that you're writing, the order of x plus y and y plus x doesn't matter. And you can program that into the engine to say, like, yeah, I don't care about the, you know, community, the associative property of addition or whatever is true for this rule. So like, just find all those variations for me. And there are a bunch of other deeper features, like there's some basic typing information already, but we want to do a better job integrating typing information from the AST, as well as deeper analysis features like data flow or local taint tracking. You know, happy to talk more about that if you're familiar with the kind of static analysis world. So, okay, to get to the question in the chat from Bakwun, here's a cool example of using Semgrep to do autofix. So if I click into here, let's imagine that we have a developer who is writing some code. They're using listen and serve. And we happen to know that listen and serve TLS is what we want people to be using inside our application. So, we can't actually perfectly patch this for them, because to do this correctly, you need to have like a server key and some other things set up. But what we can do is get them as close as we possibly can. And then we could just like put up a diff that's like, hey, like you need to fill out these other things. I've gotten you as far as I can with a forward patch. So basically what this would look like is we're going to find this in the code. Rather than saying port 80 and nil as the handler, we're going to extract those away. So we're going to say like adder and handler. And then I'm going to want to say http.listen and serve TLS is my fix. The arguments for that have the address as the first thing, then they have a cert file and a key file and a handler. So I just know this, but you can pull up the documentation if you want to see exactly like where these variable names come from. They just come from the arguments to listen and serve inside the documentation. So the cool thing here is I'm using the exact same syntax for the autofix that I was using for the code. And now if I run this, we should see, hey, like we've got this message, found an HTTP server without TLS, use HTTP listen and serve TLS instead, and we're linking to the Golang documentation. And I can just click apply fix, and you can see it successfully moved nil to be the last argument. It kept :80 as the first argument. So that's super cool. Behind the scenes, here is like us specifying that message and us specifying that fix inside the YAML file. So this is really cool to be able to set up inside CI. And actually, we just got an editor extension in beta. So you can actually set this up in the editor, which I think is ideal because if you're going to set up some sort of linter rule like this, the earlier you can complain about it and actually educate like the other person on your team who might not know what is your way of doing things, the better. And then the last feature I'll show you is one that you might have kind of seen in the UI, and maybe if you were following along, you've already done. So coming back to our very first example, wouldn't it be cool if like rather than having to do all the copy and pasting, we could have just highlighted the code here and asked Semgrep to automatically suggest some variations and patterns that would match this example. So in fact, we can do exactly this. So this was actually, believe it or not, an intern project at my company that a really, really talented intern from CMU built. She did a fantastic job. So you can see I just took one of those examples, and now when I run it, I have generalized from line 12 to lines 12, 13, and 15. So that's pretty cool. Please go forth and be dangerous. File feedback. We're very responsive on Slack, and we're really responsive to GitHub issues. This is an active open source project, and it lives and dies through the feedback of users. So if you want to get started right away, you can just brew or pip install Semgrep. There's a default R2C config that you can run on some local code, or I would highly recommend going around and playing with the live editor. If you thought this presentation was pretty decent, or it could be better, that's because of the feedback of prior people who have listened to me chat. So I would love it if you could go to r2c.dev and fill out a survey just to give feedback and help make the presentation better for the next meetup. But yeah, thank you so much for your time. I really wish I could have been in Singapore in person, maybe next year.